Bonsoir à tous et merci d'être présents avec nous pour cette présentation. Je viens de voir que l'autre... Pardon. Donc je viens de voir que l'autre présentation était quasiment terminée. Du coup, on va attendre 5 minutes avant de lancer la nouvelle. Le but étant de permettre aux personnes qui suivaient le précédent sujet de nous rejoindre. Donc, je tiens à vous remercier pour votre présence au nom de WeScale, de l'équipe de la Chaos Week. Le Chaos Engineering, c'est un sujet qu'on commence de plus en plus à manipuler au sein de WeScale. On a même des consultants qui en sont férus et qui sont d'ailleurs en partie à la source d'origine de création de cet événement. C'est un sujet qui est super important pour nous aujourd'hui. Il était important de le partager avec la communauté et de présenter des talks de qualité sur ces sujets. Donc le speaker de ce soir est quelqu'un de connu dans ce domaine d'ailleurs, qui travaille à Gremlin. Je vais attendre encore quelques minutes avant de l'introduire et ensuite je m'effacerai pour le laisser présenter. Le sujet est en anglais, donc je demanderai que vous puissiez, s'il vous plaît, poser les questions en anglais, de ce fait. Et si vraiment c'est pas possible pour vous, on s'arrangera. On va tenter une traduction en direct live avec la qualité qu'on pourra mettre. Comme je disais, on va attendre encore 2-3 minutes et ensuite je vais appeler notre présentateur. Bonsoir Andy. Comme je le répète pour ceux qui nous rejoindraient à l'instant, le présentateur qui va nous présenter son sujet dans quelques minutes est anglophone, il ne parle pas français. La présentation sera donc en anglais. On pourra éventuellement organiser une traduction en live périlleuse, mais j'espère qu'il sera rempli avec succès si besoin, mais je vous encourage à poser vos questions directement en anglais dans le chat. And now let's switch to English. So I'd like to introduce you Jason. We were sharing together his experience. Jason is a director of advocacy at Gremlin. He helps companies to build more resilient systems by learning from how they fail. He also leads the internal chaos engineering practices to make Gremlin more reliable. He worked previously at Datadog, O'Reilly, and MongoDB. And I know he has made a lot of cooking with waffle iron. And we were discussing that it is not applicable to pizza. Jason, I'd like to let you now introduce yourself, if you want to add anything. And then I will take my leave and let you go with your presentation.
Yeah, merci. Thanks. So thanks everyone for joining us today or this evening. And thanks Benoit for that fantastic introduction. So I thought rather than doing a presentation about how to do chaos engineering so much, I think you're going to hear a lot about that during this Chaos Week. So I let everybody else speak to that. It's something that I know a lot of people have experience with and that you can learn from. But I wanted to share a little bit more about the data of chaos engineering, because I talk with a lot of people who ask me, how can I get started? How can I convince my manager or my boss that we should do chaos engineering? How can I prove to them that this is something we should do? Or they ask me, what can I expect from chaos engineering? You say it's this great practice and that I should do it, but what benefits will I have? And so oftentimes we hear these questions and these stories, and I thought maybe that is you. Maybe that's you trying to figure out how you, as someone who's passionate about doing chaos engineering, can help teach others and help affect others. So I figured I would share a few stories. So to start off with, I'll share about Qualtrics. Qualtrics is an experience management platform. They're a company, their product is used by over 10,000 different brands to gather customer feedback, to interact with customers. And so they're heavily invested in reliability and disaster recovery in order to mitigate the risk of downtime. Because this is important when you're serving end customers, when you're the representative for 10,000 other companies, they're counting on you. So Qualtrics wanted to test how well they could fail over to a backup data center. Thinking of, they're in the cloud, they're fine with availability zone, but let's try regional failovers. Many of their teams run microservices. So a failover really involves restarting all of those microservices and testing those connections, basically draining a service from one data center and starting it in another, service by service. So you can imagine that if I have services A, B, and C in data center 1, and I move service A to data center 2, this means that now services B and C are missing a dependency. So how does traffic to that first data center react? And similarly, how does traffic to the second data center react when it only has service A? Then you move service B and you test again, and this takes a lot of team coordination. And this is a challenge, especially as I talk with more and more people who are asking me, how do I adopt this? How do I get my entire organization to adopt this? How do I coordinate between all these teams? Because actually shutting down these services can be bad. So just to underscore what Qualtrics does, if I click on the bottom of a website, you have often seen this, you get this pop-up, right? And this pop-up says, I want to talk with sales, or maybe I want to pay my bill, or I have a problem with the product. And it's important to be able to resolve these issues, to let customers pay you, to let customers have information that will help them use your product. So Qualtrics, rather than coordinating across multiple teams and actually shutting down services, they decided to schedule half an hour with each engineering team to test their dependencies. And they used black hole attacks to do this, to simulate those outages or those service dependency outages. Black hole attacks are available not only in Gremlin, but every chaos engineering tool out there that I know of has black hole attacks where you can shut down the network. The great thing about this is it allowed them to, each team to independently operate. So they were able to, rather than coordinate across multiple teams and actually shut down services, by talking with each team, they were able to deal with over 40 teams in less than 3 months. And it saved a huge amount of time. So they were able to work with this and work with each team asynchronously, coordinate everybody, and ensure that things would work without having to schedule everything organization-wide. The goal behind this is obviously that we want our systems to be more reliable. And this is Gremlin's overarching mission, is that we want to build a more reliable internet, right? It's pretty straightforward. But the way that we found to do that is that you have to be proactive about improving your reliability. When we think of chaos engineering, it's not just enough to do chaos engineering. Chaos engineering is a part in a much larger practice to be proactive about our reliability, rather than to wait for outages and respond to them. I will say that if you're interested in Gremlin, I'm not going to talk too much about Gremlin, but if you're interested in more, or if you want to get some free stickers, go ahead and go to gremlin.com/talk/chaos-week. So we'll have free stickers and information there. But let's move on, right? Chaos engineering. This is often what we say is chaos engineering, that it's thoughtful, planned experiments designed to reveal the weaknesses in our systems. And we say this because it's easy to remember. It plays into the idea that we don't want weakness. We want strength. We want strong systems. But in my years of doing chaos engineering, and as I've evolved how I think about it, I think this is wrong. Chaos engineering isn't really about improving our systems, or at least that's not the direct result of it. So I like to say that chaos engineering is thoughtful, planned experiments. Yes, we do experimentation. That's how we do chaos engineering. But the goal is to improve our understanding of how systems work, right? Your systems are only as good as your engineers. And so if you're thinking, how can I improve my systems? You first have to think, how can I improve the engineers, yourself, your team? And that's by improving understanding. And so once you understand a system better, naturally you will build a better system. And you'll also respond to outages better because you understand them. So just to underscore the point, and I'm sure other speakers will make this point as they discuss more about chaos engineering, but the first is that it's a process. It's not random. You need to be very intentional about the process in order to learn, in order to benefit from it. The second is that the biggest benefit is the focus on learning and validating your understanding. We work with highly dynamic, complex systems. As you automate your deployments and deploy more frequently, that means whatever you're looking at is different from when you last looked at it because the code has changed. It means that the infrastructure has probably also changed because we're working with ephemeral infrastructure that's constantly going away and new systems are replacing them. So understanding all of this can be challenging. But if you remember back to maybe when you were a kid and somebody told you how something worked, but you thought, that kind of makes sense, but let me take this apart just to see it for myself, right? I did that all the time as a kid. I'd get a new toy for Christmas. And after playing with it for a while, how does this work? So grab a screwdriver, open it up, see what's on the inside. Think of chaos engineering a bit like that. The more you can understand about how something works, the better you'll be able to deal with it. The third is that you have to then use this knowledge to obviously improve your systems. The more you know, the better you can make things. If you don't know enough about a system and you act, you can often make it worse. So knowing more is important. And then finally, as you continue to do this, you'll build a practice. And ultimately, you'll be able to then begin to automate things to guard against those regressions. So back to qualtrics and working with them and them working with teams and black holes. A lot of companies are seeing value from using black hole attacks. So let's get into some numbers. Looking at black hole attacks, from Gremlin's perspective, as I looked into the data of what our customers are actually doing, it's the second most popular attack. In the first 3 months of this year, almost 6,000 attacks were run just for black holes. And the reason is pretty clear. So we ran a survey earlier this year. My screen is shifting. We ran a survey earlier this year about what people were seeing in terms of outages, severe outages, SEV 0 and SEV 1. And it turns out that 40% of respondents said that 1 in 5 incidents was caused because of a managed service provider issue. And this underscores why Qualtrics was testing failover, because As much as we think the cloud is reliable, 20% of incidents for a lot of people are caused by cloud failures. If we look at further into dependencies, if we look at external dependencies, maybe not your cloud provider, but some third-party service that you're using some external API, we found that over half of the respondents said that 20% of their incidents were caused by a third-party dependency outage, right? That's over half. So if we look at internal dependencies then, things like I'm reliant on another team in my organization, almost 60% of respondents said that 1 in 5 outages were caused by an internal service dependency error. If we dial that in, a third of the respondents to this survey said that up to 40%, or over 40% rather, of incidents were caused by dependency failures. So that means that using black holes to test for dependency outages and to test for failovers is critical. Dependency outages, whether external, internal, or cloud, are a large part of the major incidents that companies are seeing. So I wanted to dive a little bit more into some of these numbers, and let's chat a little bit about this survey that we ran. We ran what we call the state of chaos engineering. We had over 400 organizations represented in the survey. So a lot of times people come to me and they say, we'd love to do chaos engineering, but my company isn't ready. We're not Amazon, we're not Netflix, we're just a small startup, or they'll say the exact opposite. We're a legacy company. We're a bank. We've been around for 100 years. We're very slow at adopting things. We're not ready. In our survey, though, we actually had a large range of companies. 20% of the organizations represented had over 10,000 employees, while another 20% were from companies that had less than 100. We also saw that many of these companies are enterprise or legacy companies. 25% of the companies were over 25 years old. 14% of the companies were new. They were less than 2 years old. So thinking of startups. A lot of times people say, well, I'm not a technology company. Again, maybe I work at a bank. Well, in our study, we found that yes, half of the companies were software or software related. But a quarter of the companies were finance companies like banks or insurance companies. And there were also retailers, manufacturers, and service providers all mixed in there. A lot of times people say, well, yes, but you're cherry picking. You're choosing all the people that are on the leading edge. They're using Kubernetes. Maybe you're doing service mesh with Istio. They're doing all of these fancy technology things. And you'd be wrong. Again, we had a wide variety. 58% of the respondents said that more than half their workload was in the cloud. So 40% of the respondents of this 400 were not primarily in the cloud. They were primarily on their own data centers. Less than half had most of their workloads in containers. Only 40% were actually running Kubernetes. So there's a lot of information here. If you want to download the full report, you can get that at gremlin.com/state of chaos engineering. And I'll post that link into the chat later and have it up later. But let's examine who is actually doing chaos engineering. Companies between 5,000 and 10,000 employees are leading. So rather large companies are finding a lot of benefit. Over 75% of companies in that size, from 5,000 to 10,000 employees, have tried chaos engineering. But that doesn't mean that everybody else isn't doing it. Across the board, with the exception of super small companies under 100 people, almost every company is, or at least companies of every size, are generally 60% to 75% of them have tried chaos engineering. So if you haven't tried chaos engineering, you're definitely a late adopter. You should try chaos engineering. Almost everybody else has at least tried it. But if we start to look a little bit more, we can see that all of these companies are starting to regularly run chaos engineering as well. So across the board, roughly anywhere from 1/3 to 50% of companies, regardless of size, have actually started to regularly, that means quarterly or more, practice some sort of chaos engineering. Often that starts out as game days or simple experiments. Now, the other question that people always ask me is, well, I can't run it in production, right? I heard that I should just do it in production. And I like to tell them, well, no, you would never do that with your code. You start it in development, you push it to staging before you push it to production. And we're seeing this across the board with chaos engineering as well. 63% of companies have run chaos engineering attacks in development. 50% of companies have run it in staging, and a little over 1/3 have finally made it to production. So eventually people are getting there, but they're starting in development like they should and getting comfortable before moving into staging, before finally moving into production. So I mentioned that black holes were the second most popular attack. What kind of attacks are people running? We're generally seeing that those network attacks, like black hole attacks, are the leading type. 46% of attacks that users are using are network level attacks. So black hole, latency, things like that. So the top 5 of attacks, CPU, consuming CPU is great for verifying your monitoring, validating your auto scaling, and it's just an easy way to start off. That's the #1 most popular attack. Black holes, as I mentioned, was second, good for dependency testing. Latency is third. So oftentimes what people do is they'll start with a black hole attack, but we know that our systems are rarely just up or down. There's often an in-between where performance suffers. So latency is a good follow-up to black hole attacks. Shutdown attacks are fourth. We see a lot of use of this to validate automatic restarts. For example, in Kubernetes, killing a pod or a deployment and ensuring that Kubernetes brings that back and doesn't end up in a crash loop. Or things like EC2s and ensuring that your auto-scaling groups actually work. And then the fifth in line is memory, so consuming memory. And we know that a lot of systems consume a lot of memory, or you have limits in things like Kubernetes that will prevent other services from starting. So you want to ensure that you have enough memory available. So that's a lot of numbers. I'll let that sink in, and let's chat a little bit more about another use case. We've worked with a security company, and because they're a security company, I can't mention their name, but I guarantee you that you've heard of them for good reasons. But due to a strict separation of duties, they're secure after all. Like many companies, developers don't have access to infrastructure. So we help them provide a way to implement the controls while allowing developers to test. Similar to Qualtrics testing their services, this company tested their services, but they decided to run those latency attacks. As mentioned, this is a good way to follow up because their services are rarely just up or down, but failure often looks like performance degradation. So how would the overall application perform when individual services were slow? Well, they started off small, as you do. 50 to 100 milliseconds of latency. Let's see what happens. And everything went okay. This is great. So with chaos engineering, we say that you inject failure, you analyze it, and then you repeat. So they repeated and they ramped it up to 100, between 100 and 99 or 999 milliseconds, so almost 1 second. And they noticed that things got slow, but generally they were fine. So you do the experiment, you analyze, you repeat. They turned it up to over 1 second, and suddenly everything began to crash. The worst part about this is, well, with chaos engineering, you can easily stop that. But what they also found was their monitoring tool did not actually reflect this. And this underscores why the important part of chaos engineering is learning. It's finding these discrepancies in how you think something works versus the reality. Obviously, if your monitoring is not working, that's a really bad thing. And thankfully for this security company, it was just a test. So they were able to stop the attack. They were able to address things to work on their monitoring. But who remembers this outage from the beginning of the year? Everybody had a wonderful holiday for the New Year's. They came back to work on January 4th, and Slack was down. So I contacted Slack. I talked to them. I got a copy of their incident retrospective on what happened. And one of the things that made the Slack outage so bad was their monitoring. Their observability platform essentially went down during this. And because their provisioners to create new instances was also down, they couldn't spin up new monitoring platform. This means that they had to literally query the metrics backend directly to debug the issue. Imagine not having Grafana or dashboards and having to use curl to talk to the Prometheus endpoint and get that endpoint and then scan the data in order to figure out what went wrong. That's a nightmare scenario. So chaos engineering, testing these things, ensuring that your monitoring works is so important. One other quick story. As mentioned, a lot of people that are adopting chaos engineering are not the tech companies. They're not the Netflix and the Amazon and the fast-moving startups. They're banks. So I've been working with JP Chase. They're the world's largest bank by assets. So they have the most money out of any bank in the world, and they're doing chaos engineering, which is amazing. They're starting to adopt new practices. So I recently helped them run a game day, a day of fun. They have a team that's going to do a game day. They say, we're just going to have one big meeting for this day. We're not going to do any other work. Everybody will order food in. We're going to hang out. We're going to run attacks. We're going to learn and have fun as a team. The way that they do their game days, they have one small group that's launching the attacks, and then they have the rest of the team respond to the attacks. And this is a fun way to make it a game. To essentially, the one group launches an attack and says, can you see what I'm doing? And can you remediate it, or can you solve it? It's a good challenge. But as a big bank, there's a lot of controls. And so they launched one attack, and the dialogue went a little bit like this. Engineer 1 says, okay, they've launched the attack. I'm seeing the issue or an issue. I think they've killed the process. Second engineer says, great. I logged into the machine. I ran PS. Yes, the process for the service is gone. First engineer, okay, so we just rerun the script to restart it. Fantastic. This should be an easy job. Where's that script? Oh, that script it's in the normal location. So location to script, just enter that. Oh, second engineer, I don't have access to that script. Oh yes, this is a bank. Everything must be very secure. Okay, first engineer, well, I have admin permissions. I'll just go in there and adjust some permissions. Give it a try now. You should have access. Second engineer, oh no. I think we just set off an alarm with the InfoSec team. I think we're going to get a call soon that we've done something wrong. So over the day, this team ran 7 exercises, but I think this underscores the value of running things and treating things like incidents and learning from them. They ran 7 exercises, and the big takeaway from this was that a lot of the things that they had built were perfectly fine. The service that they had built was great. That script that would have restarted things, that was fine. But there was a lot of documentation issues. And it really validated that their work was good, but the learning part, the knowledge sharing, was really what they needed to work on. Overall, the biggest thing is that they learned a lot. And that was the #1 response that we got from the team was, this was fantastic. I had so much fun and I learned so much. So focus on the learning. You'll find things like this that may not be technical issues, but might be process issues. And you need to learn about them. Because let's face it, if you are in an incident and you didn't have the permissions to fix it, but you knew how to fix it, that's a really bad place to be. So let's talk about a few more results and maybe what's next, especially for you and your organization. What can you expect? Well, again, we surveyed all these companies. We found that 40% of people said that after doing chaos engineering, they found that they increased availability. 45% said that they had faster times to resolution. They were able to resolve issues faster. 40% said that they had improved their speed to detection of issues. So they improved their monitoring. They were able to find issues earlier. The big thing is that 38% said they just had fewer defects shipped. So less bugs shipped to production meant less outages and less pages. So you can get the State of Chaos Engineering report at gremlin.com/state of chaos engineering. But a few other things that we found that teams that frequently run chaos engineering experiments have over 99.9% availability. This is fantastic. This is a correlation. I don't know if one causes the other, but I will say that adopting chaos engineering does allow you to have better availability. 23% of teams found that their mean time to resolution, their average speed of fixing issues was under an hour. 60% of teams that ran chaos engineering frequently said that they were able to resolve things within 12 hours. So they've drastically brought that down. So with that, I'll open it up to questions. But again, download the report for yourself, start to read some of the information there and see how others are doing chaos engineering and the value they've seen. Gremlin.com/state of chaos engineering. And you can get those stickers, gremlin.com/talk/chaos-week. We'll do questions. I think you can submit them in the chat, and Benoit will help me to approve those questions and highlight them.
Yes,
and then if you have any questions, if you have any questions after, if you think of something tomorrow or next week, feel free to email me or message me on Twitter.
So we had a lot of comments about how this topic is interesting, but for now, no question.
Great.
Let's wait.
Well, as mentioned, if you think of questions after today, feel free to contact me, and I'll be hanging out for a bit here.
Oh, we have one question here. Don't you think chaos is not only about the tech stuff, but also about how people works and process?
Yes, absolutely. I think primarily it's about the people stuff and how people work in the process. Because ultimately, as I mentioned, the people build the technology. So if you focus on the people first, the technology will naturally come.
Next question is more a personal question. Andy is asking, what was your favorite experience in your career?
Oh, that's a rather broad question, but I think in terms of chaos engineering, I would say my favorite experience was actually when I joined Gremlin. So I joined Gremlin last year, January 2020. And one of my responsibilities was to join and to run the chaos engineering program within Gremlin. And so prior to that, I'd been at Datadog. I'd helped with chaos engineering there. I'd seen how it's been done when it's been established, but I never got to create a program for myself. And that's both fun and extremely challenging because you find that everybody's working on a cool product. They've got all of the things that they're supposed to be doing. And so you ask them, well, can you take some time and do chaos engineering? And there's always this little pushback of, well, I don't have time for that. Or, how can we do this? So working with the team to iterate, I had built a process where we run chaos engineering experiments in 30 minutes. with just 3 engineers. And it's been a fantastic experience to build this process and to iterate it and change it and see how it could be best done.
We have another question, but I think it got answered in the comments. Yes, so if anybody hears it, the presentation is recorded and YouTube will process it when we end the live, and the video will be available in a few minutes. Any other question? Oh, we have a message from Andy. He is thanking you.
Yeah, it was definitely a great opportunity. I'm glad that they offered that to me.
I think we are done here. So I just end by thanking you, Jason, for being here with us. I think the presentation went really well and it was appreciated by our public. So I'd like to thank you, and I think we'll end it here.
Thank you.
Oh, sorry, just another question. How is your feeling about chaos engineering tools today?
Yeah, that's a great question.
The other question is about the favorite tools you are using.
Yeah, okay. So sort of a 2-in-1. I think we're at a fantastic point with chaos engineering tools today. We're starting to see more tools. Obviously, I know a lot of people have been talking about Litmus Chaos. There's Gremlin. There's Chaos IQ, or Chaos Toolkit. There's so many tools available. We've gotten to the point where Amazon has AWS FIS, so you can start to work with that in your AWS account. Azure is working on a tool. We're starting to get to the point that there's going to be a lot of tools available. And so doing chaos engineering will become easier from a technical perspective. I think what we're going to see is the struggle really for chaos engineering is less about the tools and more about the mindset and getting the adoption and getting engineers to think a little more critically about how they think about the tools that they're building, or the systems that they're building. So I'm excited for that, because once the tools are in place, it makes it easier for that fundamental shift in the way that we think. And that's the exciting part. In terms of my favorite tools, obviously I work at Gremlin. I do like Gremlin though. Prior, when I was at Datadog, that's where I got introduced to Gremlin. So I love working with the team that I'm at and building a tool that I really enjoy using. But in terms of other tools, I use a lot of tools. That's one of the fun parts of my job, is I get to play with a lot of different tools. So having fun with Kubernetes, I still really like the Istio community and what they're doing there. Istio is extremely fun. Yeah, there's just a lot of stuff out there.
Thank you. We missed a question. Michael is asking where we can find any information about your customer, and is it available on your website?
Yes. Let me see if I can't pull that up. I believe we should have a listing of customers. I will post that link into the chat, I think.
Okay.
Yeah, just gremlin.com/customers.
Thank you. We also have another question from Sinos. In your opinion, is it interesting to initiate the chaos engineering process in a simple application? Is there a minimum size where chaos becomes interesting?
Yeah, I mean, yes, you should start as simply as possible, just to try it out. So simple applications are good for that. But I think, in terms of where things become really interesting tends to be once you have applications that are a little more interconnected, where they have external dependencies and other dependencies. So, for example, if I have just a simple application that's Nginx with a static web page that says "Hello World," well, that's probably not so interesting when I, take it offline or I can consume CPU. But it becomes interesting once I'm in an environment where I have a service that depends on other services, or that other services depend on me. And we can start to see how interconnected things are and how they relate to each other.
Okay. Thank you. Any more questions? I can't see any more questions. I think this is going to be the end. So once again, thank you, and stay safe.
Thanks.
Et merci à tout l'auditoire. Hein. On va revenir un petit peu en français pour terminer. Merci à tous d'avoir été présents et merci au nom de WeScale et de l'équipe. Au revoir.